Hi everyone and welcome to STEAM Time. My name is Dayna. I'm the Buena Vista Branch Manager with Monterey County Free Libraries. For today's STEAM Time, we are talking all about capillary action. And we're going to do that by conducting an experiment that often is called walking water or walking rainbow water. And it's a simple experiment that you can do with things that you find around the house. So stay tuned. I'm going to tell you exactly what you need to do the experiment with me, and then we're going to talk a little bit about what capillary action is. For today's experiment, you only need a few things. To get started, you're going to need glass jars, any size you have on hand. The minimum amount you want is 3. I have 6, and that's because we're going to be staggering water, empty, water, empty. So every other one will have water with food coloring in it. You're going to want paper towels, a nice absorbent type of paper towel, food coloring or watercolors. I have 4 different colors that I'll be using, and then a pair of scissors to cut your paper towel if you need to, depending on the size of your jar, and then something to stir your food coloring and water mixture with. And then that is all you need to follow along with me as we learn about capillary action. So stay tuned. I'm going to walk you through the science behind the experiment and how it involves rain and plants. So stay tuned and let's learn together. So let's talk about capillary action and how it works. This diagram shows how the process works, and it starts with rain falling from the sky to the ground, where the soil soaks up all of that rain, and it's absorbed by the roots that you see here deep in the ground, and those roots take the rainfall, and they take it from the soil, and it then begins to move up the plant stem from the roots to the leaves of the plant through tiny narrow tubes called xylem. And these are vascular plant tissue, so that's what xylem is. And capillary action, it's the ability of a liquid, so in this case, the rainfall, so it's the ability of rainfall to flow upward, and you see that upward arrow, to flow upward against gravity in a narrow space. So in this case, those xylem tubes are helping carry and transport that water upward through the plant stem to the rest of the plant. And we're going to be seeing that in action today through our walking rainbow water experiment. And that's going to work because we're using paper towels. And paper towels are made up of cellulose. And so when we do our experiment, the water from our jars is going to flow upward through the tiny gaps between the cellulose fibers of our paper towel. And so the gaps that are in our paper towel, they function like those tubes, pulling the water upward. And so we'll see that in action. And then the water is able to defy gravity as it travels upward through the plant stem, but in this case, upward through our paper towel into the jars due to attractive forces, so between the water and the cellulose fibers of the paper towel. So let's jump into the experiment and see capillary action at work. Now it's time to get started with our walking rainbow water experiment. And to do that, you want to get your jars ready. I'm using 6 larger mason jars, and every other one is filled with water. So I have 3 filled with water and 3 are empty. And I put them in a circular shape. You can put them in a straight line. So once you have your jars lined up the way that you would like, it's time to get your food coloring ready. So with larger jars, you're going to want to add more food coloring. So I'm going to do quite a bit of purple in this one. And it looks like I only need 3 colors this time. So let's put some glue, make sure the water's pretty saturated, and then I'm going to do a green. Make sure it's really, really colorful in there. Okay, so I have my mason jars now filled with water. I'm gonna give it a quick stir, each of my jars. That's pretty good. Okay, now the important part. You're going to need your paper towel, which has the cellulose. That's what this is made of. So I just cut small strips of a standard paper towel, and I'm actually going to fold mine in half like this. And depending on the size of your jar, you might need to cut your paper towel a little bit shorter. I have larger jars, so I want to make sure that mine actually reach inside and over. So let me fold. So let's take one strip. So I'm going to take my folded paper towel. I'm going to stick it inside of my mason jar that's filled with water and food coloring. You might have to bring your jars closer. Let's see, up and sometimes it helps to tuck it a little bit too, if it's not long enough. There you go. And you'll see the water's already starting to creep up the purple one. And so you're just going to start sticking them in like this, up and over. They're going to create little paper towel bridges over the top of each mason jar. And you're going to want to do that until you have a paper towel inside and over the next jar. So you'll see. And if you need to scoot your jars closer, go ahead and do that. Okay, once all your paper towels are inside, you are going to start to see the water begin to creep up the paper towel. So it's using that capillary action where the water is being pulled upward against gravity, and it's going to be pulled up the paper towel just like a plant stem. And once the paper towel with that cellulose has absorbed all that it needs to absorb, it's going to then deposit colored water into the empty jar. So that's how the walking water happens. The colored jar with food coloring is absorbing all of that colored water. And when that paper towel gets too saturated, it's going to deposit it into the empty jar and then continue on around all of your jars. Now the process is not instantaneous. Depending on how much water you're using and how saturated your paper towel becomes once it's in the jar, it may take a few minutes. So it's the type of experiment where you will see an initial reaction, and here you can see with the blue, the water's already starting to creep up the paper towel, and that's the initial reaction. If you give it some time and let the paper towels really sit inside of the jars and absorb that water, that's when you'll start to see the color mixing happen. This is about 25 to 30 minutes. I decided to wait a bit longer, and as you can see, the paper towels are becoming completely saturated with our colored water mixture, and it's starting to drip into our empty jar, and the colors are beginning to mix together at the bottom. The paper towels are absorbing all of that color through that action, that capillary action. It's moving upward through the paper towel, and now it's collecting into our empty jar. And I want to talk about other aspects of science that are at play with this experiment. So water molecules, they like to cling to cellulose. So those cellulose plant fibers, which is in the paper towel, it clings to this, and that process is called adhesion. And the water molecules are also attracted to each other. And so they stick close to each other through a process called cohesion. So as the water starts to move up through the paper towel, it's helping to fill those tiny gaps in those cellulose fibers. And the cohesive force is what's helping to draw more of that water upward. As you can see, it's starting to go upward and then down back into our empty jar. And so as the experiment continues and as those paper towels absorb more and more water, the adhesive force between the water and the cellulose fibers in the paper towel, as well as that cohesion between the water molecules, that's actually going to start to it'll be overcome by the gravitational force of the weight of the water that's in that paper towel. So the paper towel is becoming so saturated that it's just getting heavier and heavier and heavier. So once you get to that point, the water can no longer travel up the paper towel. So that's why if you do this experiment, play around with different levels of water as well as different lengths of paper towel. Will it help the process happen more quickly if your paper towel is a bit shorter and you use a smaller container? Is it helpful to have more water in your jar? So play around with that because that will definitely change the experiment. So we were able to learn all about capillary action today. We learned some new vocabulary words. We learned the word xylem, those narrow tubes in the plant stem. We learned adhesion and cohesion. And we got to make beautiful kind of watercolored paper towels. If you let them dry out, you can actually save them and use them for a future craft project. It kind of has a really cool tie-dye effect. But I'm at the 30-minute mark. Feel free to leave it longer. Come back after an hour and see where you're at. Let it go a few hours and see how much water you can get to accumulate inside your jar from your paper towels that you have. Thank you so much for joining me today, everybody, for STEAM Time, which was focusing on capillary action and walking water. If you're interested in learning more about these science concepts, definitely check out our online catalog at emcfl.org and see what books our library has available on the various science concepts. You can always place a hold on an item and then pick it up via curbside at your local branch. Thank you so much, everybody, and I look forward to seeing you next time. Bye-bye.